Okay, all right. So this is lesson 12, factoring, quadratics, and special factorizations. Let's talk about the word factor real quick. So if you see the term factor, just think that means to write as a product, to write something out as multiplication. It may have been addition at first, now write it as multiplication. So the purpose of doing that is so that way we can use the zero product property to solve equations, okay? There's other things that we can use factoring for, but that's one of the first things that we'll do. So, one way to think about it is here's something that is written as like a standard polynomial, okay? It's two separate terms. You could factor that as x plus 2, x minus 2. So we took something that really just relied on addition and subtraction and wrote it out as a product, right? To write something out as multiplication. There are some special cases. Notice I just used this one here. This is called difference of squares. It's called that because it's something squared minus 4, which is something squared. And so that x and that 2 goes here and here. Okay, and so that's me using difference of squares. So here's some special cases, such as the difference of squares, something squared minus something squared. Okay, that's a difference of squares, so I can use this trick to quickly factor it. And you want to learn that trick, especially. If you learn none of the other ones, this is the most important one because you will see it so often. There's difference of cubes, right? You could do that. Difference of cubes. You can do sum of cubes. Okay, those are the three main special cases. Okay, well, let's go ahead and start putting this stuff to work. Let's solve this equation. First of all, we're going to use all the tools that we know at this point. So this looks like something that's going to require multiple solutions. So I'm going to have to factor it out. And in order to use the zero product property, right, to benefit from the factoring, I need to get it equal to 0. So I'm going to subtract 12x from both sides to cancel it out and give myself 0 on the right side. So that's going to be 4x cubed plus 8x squared minus 12x equals 0. Okay, right, subtracted 12x. So that way it's set equal to 0. Good. Now I'm going to look for a common factor, right? My greatest common factor. And if I'm careful, right, I might notice that all three terms are divisible by x, right? They all have an x. This one has 3 x's, this one has 2, this one has only 1. So they all have 1 in common. They all have 1 in common. So x comes on the outside. Looking at the numbers, I see 4, 8, and negative 12. All of those can be written as 4 times something, right? This is 4 times 1, 4 times 2, negative 4, but 4 times 3. Okay, so I can factor out that common 4. Okay, so I took away the 4, scratch out that one, and one of these 3 x's, that would leave me with x squared. 1x squared, that is. Of course, you usually don't put the 1. Factored out the 4, so I'm left with 2. Took away one of those x's, so 2x. And then I took away the 4, literally, and I'm left with just a 3. The x has been factored out, so it's not there either. All right, there we go. So 4x times x squared plus 2x minus 3. Now this is a quadratic, and we'll factor that really quick. Okay, how would I factor that? Well, there's different methods. I'm going to use a little shortcut, I guess, because it applies here. One little shortcut that you might notice is if there's an understood 1 here, you really just need to focus on this negative 3. I'm looking for two numbers that if I multiply them together, they will equal that negative 3. Okay, but if I add those same numbers together, they will equal this positive 2 here. And so I run through a list of numbers in my head, and I come up with negative 1 and positive 3. Negative 1 and positive 3. Right, those two multiply together and give me negative 3. They add together to give me 2. And so I can jump straight to the factored form. All right, I don't want to go through the whole process here. We'll do that later. X minus 1, there's that -1. X plus 3, there's that plus 3, right? So these two numbers here, X minus 1 and X plus 3. All right, so now we factored it all the way. Okay, we have 3 factors essentially. Zero product property says that I can set them individually equal to 0. So 4x could equal 0. X minus 1 could equal 0. X plus 3 could equal 0. Okay, well, let's solve the one on the left. If I divided 4x by 4, I'm left with x. 0 divided by 4 is 0. Okay. I can add 1 to both sides to get x equals 1. I can subtract 3 from both sides to get -3. So here are my 3 solutions. 3 solutions. Okay, so yeah, we didn't spend a lot of time on the factoring part, but it's good to review that. We can always talk about that some more later. Okay, here's an odd looking question, right? It looks odd. So let's kind of dissect it. We have 3 functions that are given to us. F of x, maybe I'll color code it a little bit. F of x, g of x, and h of x. Okay, these are my 3 functions. One's a quadratic, one's linear, one's constant. And we're asked to solve this equation, or the equation that's produced by this expression here. So let's write it out. F of x is on the left side, and it's 5x squared. And then this right here means g of x minus h of x. G of x is 5.5x minus h of x, which is 1.5. Okay, this is what I'm trying to solve. All right, and so there's a few ways you can look at this problem in particular, but I see this 0.5, read that as halves, right? These are halves. And so if I wanted to get rid of a half in a problem, I could multiply through everything by 2. Doing that would actually eliminate all the decimals. That's one thing I could do. I could multiply everything by 10, which would bump the decimal over, but that would give me some really big numbers. I'm just going to multiply by 2. So if I multiply this by 2 and this by 2 and distribute that 2, I end up with 10x squared equals 2 times 5.5. It's 11. 2 times 1.5 is 3. So 10x squared equals 11x minus 3. So that's what I'm going to work with. 10x squared equals 11x minus 3. It's a quadratic. Let's get it all, everything on one side so it can equal 0. I'm going to subtract 11x from both sides. And I will add 3 to both sides so that there's nothing left on that right side, 0. All right, now I'm going to factor this out. There's different methods, of course. There's trial and error. Let me go over the long way to do it, right? The AC method, because that's probably the most complete method of the ones that you've been taught. Okay, so the AC method says to take the first A, right, first coefficient, and the constant at the end, C, multiply them together, 10 times 3 equals 30. So now, like on that other problem, I want to find 2 numbers that when they multiply together, they equal 30, right? The product of 10 and 3. But if I add those numbers together, I get -11. Okay, so I'll go through some numbers in my head. And I like the idea of -6 times -5, because those multiply together to be a positive 30. But if I add -6 plus -5, I get a -11. Okay, so those are my 2 digits that I'm going to work with here. So I'm going to use those numbers to split this problem into a few extra terms. Okay, so it's color coded so you can see where that -6 and -5 came from. Of course, it's here. Also, notice if you were to combine these two like terms, you would get -11x, right? So these two expressions are exactly the same, right? They look different, but they mean the same thing. So from there, okay, from there, I will group together the first two terms and the following two terms. Okay, so recap so far. Get it equal to 0. Split the center term, right? That b value, if you're looking at ax squared plus bx plus c, b is the term you split. Group the first two and the last two terms together. Use parentheses for that. And now for each of these, factor out the GCF, the greatest common factor. All right. 10 and 6 are both divisible by 2. All right, this is 2 times 5 and 2 times 3. So 2 can come out. This is x times x. This is just 1x. So they have a common x as well. So 2x is my common factor here. That leaves me with 5x minus 3. Okay. Remember, you can always verify this quickly in your head, right? 2x times 5x is 10x squared. 2x times -3 is -6x, right? So you can check to make sure those two things need to be equivalent, right? Okay, so now here, this set of parentheses, we want to look like this one, but it doesn't. It's close though, right? The only thing different is the signs are wrong, right? And so if that happens, just factor out a negative, like literally factor out the negative, because that's an understood -1. And -1 times a positive 5x would give you a -5x. And -1 times a -3 would give you a +3. So factoring out the negative will just flip the signs for you. All right, so the two parentheses match. Look at this as two separate terms. Okay, notice they have a common factor, right? 5x minus 3 is the common factor. So I will factor out 5x minus 3. If I factor 5x minus 3 out of this term, I'm left with 2x. If I factor out the 5x minus 3 from this term, I'm left with -1. All right, there we go. I factored it. Now all that's left to do is to use the zero product property to solve two equations. The first one is 5x minus 3 equals 0. The second one is 2x minus 1 equals 0. Okay, add 3 to both sides, divide by 5. I get 3/5. Add 1 to both sides, divide by 2. I get 1/2. So there we go. Those are our two solutions to the original equation that was set up by this awkward expression here, right? Okay. Not so terrible. All right, let's solve this one. This one looks scary. All right, let's get all of it to one side. So 2x plus 1, x to the 4th. That x plus 1 is the exponent if you can't tell. Minus 2x plus 1, 8x. Okay, so I just subtracted this from both sides. So that it equals 0. All right, common factors. I see this. That's the first thing that I noticed, so I want to factor that out first. I also see that this and this have a common factor, right? X to the fourth and X, they both have a shared X. So I'm going to go ahead and factor out an X as well. So if I took one of the X's away from here, I'm still left with 3 of them. This was taken away. This was taken away. I'm left with an 8. Okay. And then X cubed minus 8. That's one of our, you see a cubed, right? In a constant term here. That's one of our difference of cubes, right? So how does that work? Okay, so 2x plus 1, x. Okay, if we did the cube root of this, that would just be x. The cube root of 8, remember I said memorize those, right? It's not a bad idea. Cube root of 8 is 2. Now there's gonna be a plus and a plus there. Square the first term. Square the second term. Multiply the 2 terms together for the middle. Okay. So it's factored out. I see 4 separate terms here. So let's set them all equal to 0. 2x plus 1 equals 0. X equals 0. X minus 2 equals 0. X squared plus 2x plus 4 equals 0. Now remember we talked about this earlier. That one, you can't change the exponent and expect the value to equal 0. Okay, that doesn't happen. So that's a no solution. Here, this one's solved for me. I don't have to work that one out. This one does not require a lot of work, just 2. This one right here is not actually factorable. This one's a little bit more complicated. I think typically for this type of question, if you were to see it on Alex, they would just say no real solution. Okay, you could use the quadratic formula to figure that out and get a complex solution, but I'm pretty sure we're supposed to avoid that in this section. Okay. Let's do this one because it's different enough. So the area of a rectangle is 30 feet squared. Now I know people tend to not like these word problems, right? Application problems. They're really not bad. Draw a picture. Just draw a picture. No one wants to draw pictures. Draw a picture. Here's a rectangle. Okay, this is my rectangle. You can tell because it's not actually drawn well. Okay, and we know that the area inside of this thing is 30 square feet. Okay, and you know how to find the area, right? You multiply this side times this side, the length of each side. Okay, what do I know? The length, the long side of the rectangle is 7 feet more than twice the width. Right? So the length is dependent on the width, right? I don't know what the width is, so I'll label it X. But the length is 7 more than twice the width. So twice the width plus 7 more. Find the dimensions of the rectangle. Okay, well, I know how to find the area, right? Length times width, so I'd multiply these two together, and it equals 30, right? I know the area. Once it's in this form, it's pretty much just run to the answer now, right? Distribute the X. This is a quadratic, so let's get, it said equal to 0, so let's subtract 30 from both sides. And so we can kind of ignore the context for now while we just work through this algebra here. We have to factor it. So we talked about the AC method earlier. We talked about difference of squares and other shortcuts. Let's talk about trial and error, right? So trial and error is fun if you like such things. I know that these will probably be 2x and x because they have to multiply together to give me 2x squared. Okay, now this is the part I don't know about, right? So I'm actually going to change this color because I'm pretty sure 2x and x are going to be right. What I'm not sure about is if I'm going to have a plus here or a minus here and a minus here, or the other way around. It could be the other way around. I know I have to have a plus and a minus though, because whatever numbers on the end has to multiply together to be negative 30. The only way to get a negative is to multiply a positive and a negative together. So I don't know which one's a plus or a minus. I'll leave that in red. Also don't know what these numbers are going to be. They could be two numbers that multiply together to be 30 though. So like 5 and 6 possibly. Now what I'll do is try that out. If I were to distribute, just ignore the first two and the last two, because you know that they're going to give you 2x squared and negative 30. You pick numbers so it would do that. You really just need to focus on the inside. So 5 times x is 5x. Negative, or 2x times negative 6 is negative 12x. 5 minus 12 is negative 7x. Okay, the number is right. The sign is wrong. So I just said the sign's wrong. So I need to fix my signs. So there we go. 2x minus 5, x plus 6 equals 0. Set them both equal to 0. So x could be negative 6, or x could be 5 over 2, or 2.5, right? Okay, but this negative 6 makes no sense, right, in the context of this problem. You can't have a length of negative 6, right? Not in real life rectangles. So we're going to ignore that solution. Okay, 5 over 2, or 2.5. That's what we're going to look at. So the width is 2.5. The length, what's the length going to be? Well, remember, it's 7 more than twice the width. So twice the width plus 7. That's 5 plus 7. That's 12. Okay, and so if you look at the problem, you do want to make sure everything that you just said makes sense, right? Like you want to make sure that if I found the area and I multiply 12.5 times, or 2.5 times 12, I'd multiply that out, it comes out to 30. Okay, what I have makes sense. Okay, and so there we go. That would be this whole lesson. So I'll go ahead and stop recording.